Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're returning to our Postgres Planner Quirks series to talk about incremental sort and when it goes wrong. So to be clear, incremental sort is actually a very amazing feature that got added in Postgres 13. A simple example might be an index scan that has an existing sort order in the index that Postgres can reuse, and so Postgres only needs to sort by an additional column. There are more complex cases. For example, let's imagine you have a group by, you have an aggregate function inside your queries. The aggregate function might need a particular order. And we talked previously in 5 Minutes of Postgres about all the improvements that were added in Postgres 16 around incremental sort and how to, for example, make distinct queries faster or order by distinct aggregates. However, I've recently come across a couple of cases where incremental sort actually makes performance worse. And I want to explain to you a little bit when these cases happen so that you can see them more easily when you upgrade your Postgres. Now, to be clear, this is most likely to affect you if you're either upgrading from something before Postgres 13, where incremental sort was first added, or if you're upgrading to Postgres 16, where there are a couple of improvements regarding incremental sort that make it more likely to see an incremental sort node in your query plan. We'll start with this bug report by Nicholas from Loxodata. In this example, Nicholas walks us through how a customer of theirs did a migration from 11 to 15 in Amazon RDS, and they noticed the degradation in response time on a query. The query went from a few seconds of runtime to 10 minutes. They, of course, did vacuum analyze. That all seemed good, but then when they did an explain analyze, they showed a change of plan. In Postgres 15, it shows an incremental sort responding to the order by clause on a created at column, whereas in 11, there was a more efficient index being chosen. So we essentially see different indexes being used in one case with the incremental sort node. Now, this is a variation of something that we've previously talked about, where you have an order by statement in Postgres and you have a limit, and Postgres will then sometimes use an index that satisfies the order by condition instead of using an index that handles the where clauses. Postgres does this because it thinks that it's more efficient to use a sorted result and essentially go through the rows, and once it got 50 in this case, it can terminate early, so it doesn't actually think it needs to use the whole sorted result. Whereas in the other case, it has to get all the rows that are matched by a where condition and then do the sort. Now, what surprised me, and I didn't know before, is that incremental sort actually affects the costing for cases like this. Now, Richard Guo came up with an example that's a little bit simpler and shows the same problem. So here we have a single table that has two partitions in it. And Richard generated some data, and then he creates two indexes. And we can see that in the bad case, an incremental sort is chosen, and Postgres doesn't actually use the indexes for filtering. So Postgres does an index scan, but it essentially is not able to restrict how much results it needs to look at in the index. There's no index condition here. It's only used for its order. Let's step through this example to show how the plans differ between 12 and 15 that I have running locally here. So I'm going to start with 12, and what I can see on 12 is that our index condition is used as I would expect it to, right? So this is the good plan. Now, if I go and run the same thing on 15, we can see that on 15, this is significantly slower. So even in the simple example, on 12, we got 2 milliseconds of runtime. On 15, we got 94 milliseconds of runtime. And really the main difference here is that on 15, the exact same query uses that index for sorting, and then with the incremental sort logic, essentially incorrectly thinks that this is the cheaper path. Unfortunately, we can see that even on Postgres 17, this exact same problem still exists. You can set enable incremental sort to off and rerun the explain. Now here on 17, we can get the fast query plan. Now, why is this happening? As Richard explains here, when Postgres calculates the cost of incremental sort, it needs to estimate the number of groups into which the relation is divided by the existing presorted keys to then calculate the cost of sorting a single group. Now, Postgres in this case overestimated the number of groups in the initial sort, and that way the startup cost of the incremental sort is actually underestimated, and that ultimately causes us to use the incorrect index here. Now, this estimate num groups function in Postgres is a little bit of a potential hazard, I would argue, because it really works off of limited data, and Postgres doesn't have good statistics about cross-table correlation, and a lot of the data that is available on single expressions, like for example, when you use create statistics, doesn't really make it up into this part of Postgres. And so a lot of the discussion on the community mailing list essentially revolves around how could Postgres handle this better? Now, I think Tomas Vondra summarized as well, which is the challenge is where to get usable information about correlation between columns. So this is only a problem when columns are correlated. And unfortunately, right now, this discussion is still ongoing, so we don't really have a patch. So if you have correlated columns that you're grouping by, we've seen incremental sort node come up, you may want to turn off incremental sort and see how that impacts the performance. Now I'll mention one last thing. So David Rowley in Postgres 16 added a new setting called enable presorted aggregate. There was this commit that allowed the planner to do more efficient execution of aggregate functions that have an order by or distinct clause. So this is generally a good thing. However, there is the potential for the planner to make a bad choice. And as David notes here, costing for incremental sort is not perfect as it assumes an even distribution of rows to sort within each sort group. So he adds this escape hatch here of enable presorted aggregate to essentially go back to the pre-Postgres 16 behavior. Now let's look at an example here that Pavel Lutzanov posted on a mailing list. Here we have a simple table with 3 columns, and we have an index on 2 of the columns. And now we have a query that has a group by A, but inside that grouping, it does an array aggregate of the C column ordered by C. And so we can see here in Postgres 15, what we're getting is an index scan, and then there's a group aggregate on top of that index scan. Now we're going to repeat the same on Postgres 16. And so in Postgres 16, we can see that the execution time actually went up significantly. So we're going from 280 milliseconds in Postgres 15 to 400 milliseconds in Postgres 16. And really the difference here is that we've added this incremental sort node here. Now you could go ahead and turn off incremental sort, but what's really surprising here is that despite us turning off incremental sort, we're still getting a worse result than in Postgres 15. And this is explained because the change that was made in Postgres 16 actually modified how Postgres prioritizes which sort order it needs. And so in order to help incremental sort, unfortunately, this particular case was penalized even if you turn off incremental sort. Now this is what the enable presorted aggregate GUC is for. And so if I turn this off and I rerun my query, we can see that now Postgres will pick an index scan and does the group aggregate. And because we're skipping that unnecessary sort step, because the group aggregate already can do the work, Postgres will now again have the fast query plan of 270 milliseconds. So be aware that in this case, it's not enough to turn incremental sort off. You might actually need to use that special enable presorted aggregate setting to turn off the problematic behavior. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.